Yes, welcome to our classroom. In the previous session, we have seen electric motor, right? It will convert the electrical energy into mechanical energy. Now we are switch over to generator. Okay, we are going to produce the current. That's why we are saying the generator. So there is a basic principle of generator we have. One is electromagnetic induction and second one is Fleming's right hand rule. From these two principles, the electric generator is working, right? And here we have start with electromagnetic induction. Okay, here we have start with electromagnetic induction. Who give the first idea about this electromagnetic induction means, say, Michael Faraday. He is the first person give the experimental effect of electromagnetic induction. The name itself you can know, electromagnetic. Both are relating each other, right? So electromagnetic induction. With the touching, what we are going to do? Induction means is exchanging, right? So, and here the Michael Faraday is the first person to find the electromagnetic induction, right? So what is electromagnetic induction? How we can achieve? We can achieve the electromagnetic induction in two ways. Okay, the first way is we have one coil, right? Yes, we have one conductor. This is the conductor. Okay, in that conductor we have coils. Okay, I am wounding into number of turns here. Okay, just like assume here this is the conductor. I have the coils. Okay. Okay. Roughly I wanted here. Okay. So this setup is exactly here. Okay. And this end is connected with galvanometer. These two end is connected with galvanometer. What is the role of galvanometer? To detect the current. Don't say measure the current. Galvanometer is always detect the current, not measure the current. So try to understand galvanometer to detect the current. Its role is to detect the current. Either the current is passing inside the circuit or not. Okay. Okay. When you are connecting these two ends with the galvanometer, what will happen? So here I have one bar magnet, right? Assume that this one is bar magnet and this one is north pole. I am holding in the south pole. Now I am going to inserting the bar magnet through this hole. Okay, I am going to insert. What will happen? Yes, as we know that if you are giving current, magnetic field is produced. Like vice versa, if you are applying magnetic field, the current will produce. That's why we are saying induced current. Try to understand my words. If you are providing magnetic field to that coil, okay, current is induced in that coil. That induced the current is called, we are saying, developing the current or producing the current, right, by applying the magnetic field to that coil. So what will happen? So if you are inserting this bar magnet into the coil, due to that magnetic field, the current is induced in that coil. If current is induced in that coil, then the galvanometer shows the deflections. Deflection. There is no measurement in the galvanometer. It shows the deflection either in the right side or left side. Here, first I have chosen in the left side. Okay, you apply right hand thumb rule, that will show in the left side. Now, what I am going to do, I am going to change these poles of the magnet. Here you can come here, the same diagram, but I change the poles. This is south pole and this is north pole. So now I am changing the pole direction. So initially I said I am holding the south pole and this one is north pole. Now what I am going to do, I am inserting south pole, right, first, and then move slowly inside this coil, and north pole is going secondly. At that time, what will happen? In the first case, it gives the deflection in the left hand side. Look at here, the deflection takes in the right hand side because we have changed the poles. Due to the changing in the poles, we are changing the direction of current, therefore the galvanometer deflection also shows in the opposite direction, right? As we know that very clearly, we can able to change the direction of magnetic field by the changing the polarity of the battery, right? That is why we are saying that here we are changing the direction of current, right? So that time the galvanometer deflection in the opposite direction. Suppose this coil, right, and this bar magnet both are stationary. What will happen? Nothing will happen, right? There is no induced current will produced. Okay, that's the case here. If coil and magnet are stationary, then no current detected in the galvanometer, right? This is the first case, we are inducing the current. That's why we are saying generator. This is one of the way we can, one of the principle of electromagnetic induction. We can induce the current. And the another way, we have one conductor. In that conductor, one coil here and second coil is here. The first coil is connected to battery and key. The second coil is connected to galvanometer, right? The first coil is connected with battery, key, and the other side is connected to the coil 1, and the second coil is connected to galvanometer. Okay. Now, if we close the key, what will happen to coil 1? Definitely, if you close the key, the current flow in that coil 1. Obviously, we know that. Yes. So, if current is passing through this coil 1, is there any change in that coil 2? Can you able to observe any changes in that coil 2? Yes, of course. We can able to see there is some deflection in the galvanometer. Initially, it's exactly at this position. After close this key, what will happen? It will deflected in one direction. It will deflected in one direction. So that's why I wrote here, the direction will goes like that. Direction will goes like that, right? And after sometimes few minutes, what will happen? This deflection is come back to the normal, right? That means it's saying about some instantaneous current is passing in that circuit. Yes, some small amount of current is passing by small amount of time. That's why I'm saying in instantaneous time that will the current will be detected in that galvanometer. So if you are closing this key, right, what will happen? The galvanometer shows some deflection, as in here extreme right. After few seconds, it come back to its original position. That means it's saying the momentary current, right? So, and okay, now if you are open this key, what will happen? This galvanometer shows, okay, deflection in the opposite direction because of we have opened this key, right? There is some, due to this current carrying coil, carrying a current, right? Due to that, the magnetic field is induced in that coil. Due to that magnetic field, the current is induced in that coil too. Therefore, what will happen? The remaining current will flow in the opposite direction, right? It's clear. The first case, it reflected in the extreme right side when the key is closed. After a few seconds, it come back to this normal. That means no current is passing. When we open this key, right? If you open this key, the galvanometer will show the deflection in the opposite direction, right? This is the second way we can say about the electromagnetic induction, right? Yes, that means the current, this reverse direction shows that the current is flows from opposite direction, right? And from this one, okay, these are all the two ways we are producing the current. One is here and second one is here, okay? And now we move on to this one is called Fleming's right hand rule. So take your right hand and stretch your three fingers, thumb, forefinger, middle finger, thumb, forefinger, middle finger, right? So mutually perpendicular. Stretch these three fingers and mutually perpendicular to each other, right? There is a difference between Fleming's left hand rule and right hand rule. In Fleming's left hand rule, we are getting the force. In Fleming's right hand rule, we are getting the induced current. Okay. In Fleming's right hand rule, the thumb shows the movement of conductor, and the forefinger shows magnetic field, and the middle finger shows induced current. That means we are producing the current, right? So this is a statement for Fleming's right hand rule. Stretch your thumb, forefinger, middle finger, all are mutually perpendicular to each other. Thumb indicates movement of a conductor and forefinger indicates magnetic field, and the middle finger is indicating induced current, not current, induced current, right? It's clear? I hope you understand well. Thank you. See you in the next video.